Hello everyone, today I will provide information about pile modeling in the STA program. Piles are an example of deep foundation types. They can be given as an example. Piles are used in situations where shallow foundations are inadequate, or when the soil is poor, and our soil-bearing capacity is insufficient. Piles are divided into two types. One of them is the friction pile. The other is the ant-bearing pile. In a friction pile, vertical loads are supported by the frictional force that develops between the pile surface and the soil. The most typical example of this is the driven pile. In the ant-bearing pile, the vertical loads from the structure are supported by the end resistance that occurs at the tip of the pile. The most typical examples of this are steel piles, board piles. There are many different types of piles used today. The most basic types include concrete piles, steel piles, and composite pile types that use both concrete and steel piles together. I can mention these. Additionally, I would like to touch on another important point. Pile diameter, pile length, reinforcements used in the pile, stirrups, our pile type. All of these are situations that will directly affect the outcome, and they are very important. All of this, the pile drawings, need to be obtained from pile companies. Similarly, pile bearing capacity values should also be obtained from pile companies. The values obtained from there must be provided by a geotechnical engineer. After these values are obtained, they can be processed in the program, and modeling can be carried out accordingly. This is important. In particular, capacity values also vary depending on the pile type and the soil. These values also need to correspond to the QP and QS values obtained from the tests and loadings conducted in the field, and I need to ensure that this meets the CHU value. The QS value in piles represents the friction pile. Now, I am determining how much of this CHU value I am addressing with the friction pile and how much with the ant-bearing pile. This shows that, so, saying QP divided by CHU 0 means that I am completely addressing it with QS. So, I am completely supporting the forces coming from above with the friction pile. If you have a situation like this, you can directly mark this P1 material, or it could be 50% as I mentioned, since the elastic modulus can vary. Based on this, you determine your material. Of course, you can also refer to the materials section from here. Look here. You can change the value of the elasticity modulus and the values of per and CHU to yourself. And based on that, you can make your choice. It's up to you. Now, I'm going back to my pile model. I will re-enter the values. I'm entering quickly. Yes, I enter it this way. After that, I am choosing P2. I am saying that part of it should correspond to friction pile and part to end bearing pile. I selected this option. Of course, the diameter is important. We didn't mention it at the beginning. I am entering the diameter as 80 centimeters here. After entering this, of course, we can input our piles one by one. Here, we can either write the coordinate values or draw the piles as a group. This is much more useful, and I will draw these as a group here. An important point I want to mention here. In reality, these piles are primarily placed under the wall and column on the right. Then, piles are distributed in the remaining areas with a certain distance in between. Here, of course, since I am directly showing the logic, I will demonstrate the direct modeling. However, because this is how it is applied in the field, in reality, when modeling here, the first thing that should actually be done is to add the piles under our walls and columns instead of drawing them all together. After that, the goal is to add the other piles, while leaving an appropriate interval for the remaining sections. I mentioned the concept of appropriate intervals here, which is very important. The distance between both piles should ideally be up to 3D, so the 80 centimeters here must be 3 times the diameter of the pile. So, if it is more than 3D, for example 4D, it will not be a healthy situation. Or, if it is 2D, that will also not be a healthy situation. Because, when it is 4D, the distance between them is too great. And here we have our raft foundation. Our raft foundation will come into play. When our raft foundation comes into play, then the load flow will be disrupted. The load that the pile needs to carry will be based on the raft foundation. Due to the large distance between them, the load flow will not occur correctly. Therefore, the most logical approach is to arrange them in 3D. Now, I will also explain how this adjustment is made in the group drawing. If it is 2D, then there will be a conflict between the loads, because the piles transfer loads at a 45-degree angle. In other words, the piles are transferring loads at a 45-degree angle. Therefore, a proper load transfer will not occur. Therefore, it is beneficial to arrange them in a 3D manner. Now let's quickly create our group pile drawing. Here, I need to adjust the coordinates before moving on to the group pile drawing, because the first pile program will be based on this coordinate. Right now, it shows 0, 0. This is not what I want, because I do not want my pile to extend beyond the foundation part. Here, I want the columns to be adjusted to be right at the edge. It should be suitable for that in the collective drawing. I have also created my axis to sell this. At first, that's why I am entering my axis here to be 0.4, since the diameter is 80 centimeters. Sorry, I meant to say I am entering my coordinate values. And then I click on the group pile drawing. When I do this, look, it placed my first pile, and it is formed in such a way that it will not overflow and will be perfectly aligned with the edges. After that, I will now create my other piles again. Here, I had also set my axes in such a way that they would align perfectly with the edge. Because I captured this point, I created it this way. Then, if you quickly look down, you will have created all the piles. There is an important point here. First of all, I want to say that as you can see, our interval section is visible. You can adjust this using the arrow keys on the keyboard. Our target is to be approximately 3D. Here, there are values close to 4D. If you press the up arrow key, then look, it increased the value in the Y direction. I want it to decrease. So, I'm pressing the down arrow key. I have set this to be in 3D. Similarly, we can do this in X as well. When we press the right arrow key in X, it makes the necessary reduction. Here, I made my choice based on approximately 3, which is currently 2.8. And when I clicked the mouse, it placed my piles throughout the entire structure, and it positioned them at the intervals I aimed for. Yes, the piles should be distributed homogeneously along the entire foundation. As seen here, it is not a correct approach to only install piles in a specific area, because the foundation part with the pile does not deform, while the other foundation parts without piles do deform. This leads to different settlements in the foundation and creates an unhealthy condition. This is important. If it is to be done this way, then the foundations need to be given expansion joints. Since providing expansion joints in foundations is generally not a very healthy situation and can damage the integrity and stability of the foundation, the best approach is to avoid regional pile modeling. Now we have created our piles here. I will show how to copy and offset these piles. Now we come to the floor arrangement button. We select the pile option. Then, if we want, we can select all the piles or just a portion of the piles. Here, using the mouse. Here, we can either simply copy the piles with this option, or we can also shift the relevant piles here. For example, let's do the copying for demonstration purposes here. We can bring in where we will copy to, and adjust ourselves accordingly. Of course, I am showing the logic here. We can either copy it this way, or, if you want, we can move it to any area we desire. Yes, arrangements can be made in this way, and the modeling of all piles can be created quickly. Now we will analyze here, in this particular section, and when we analyze in a very detailed manner, we will see how much it significantly reduces the overall total stress, and what significant contribution it has. Normally, before placing the piles, there was approximately a stress of 40 tons per M2 in the raft foundation here. Our capacity, as seen here, was 28 tons per M2. Now that we have placed the piles, the raft foundation will have much less load to bear, and our raft foundation will be saved. We will also see how much it has reduced in the analysis results. As a result of the analysis, where and how can we view the information related to the piles and the analysis results? Now, I will analyze our construction related to these, and carry out the information transfer. Before analyzing, I want to mention one last point about the structure. I will demonstrate it as follows. Yes, here you can see the clearances. For example, let's say I want to add a clearance in between. I will copy it here with any clearance. And after we say we have copied it, you can see that when I add it in between, there are 4 piles around it, and the distances to these piles are indicated. It also shows how many Ds there are. Accordingly, I can place my pile at a much healthier point, because I am targeting 3D. So it needs to be between 2D. For D, that's why I say 3D is ideal. Based on this, I can make this arrangement, because as I move it, look here. When it goes below 2D, the color changes too. Here, we need to stay in yellow colors. Perhaps the ideal is still to ensure a 3D aspect, in order to make sure that the visual effect is maintained, and as well as to enhance the overall appearance. It is beneficial to make adjustments accordingly in this way. While arranging and adding them, you can visualize the distances here by looking at the surrounding clearances. Carry out your arrangement. Yes, now, I will record the construction and analyze it. I had already chosen Farah analysis here. I was going to solve it with Farah analysis. This way, the options are now, yes, is analyzing. Yes, our analysis has just been completed. I will go right here to the analysis button for Roddy foundations. Here, we will first visualize our foundation stress. I'm calling my foundation here. As you can see, my piles are also visible here. And I will mesh. I am saving after meshing. Yes, I am organizing the rigid material here. Afterwards, I will save it again and analyze my Roddy foundations. Yes, it is currently being analyzed. As you can see, a stress value that was 40 tons per square meter before modeling has now dropped to 2.6. So has decreased significantly. This indicates that the Roddy foundations have not come into play, and that the load transfer between the clearances is occurring correctly. We can visualize any deficiencies in the piles from this option. When we click, I can see that everything is currently sufficient. If it were not sufficient, it would be highlighted in red. For example, when I click on one of them, the account is also displayed here. As can be seen, I had entered my simple values as 350 and 470. The incoming forces are very small in comparison. And similarly, had also selected P2 material here on the right side. Therefore, the force value that the friction pile and bearing pile are currently accommodating appears to be equal here. In other words, they are transferring the value of 21.4 here to be equal. Based on this, calculation was made, and it is 350. The value is already small in a non-seismic condition, and also comes out small at 470 in a seismic condition. The values resulting from the loadings are visible in this way. Here, we can view them for each file. It is written here for all of them. We do not have any deficiencies. Of course, you can also visualize these in the report and in the analysis results. When we click on the analysis results, you can see that we have a button for pile loads. Here, we need to click on this. When we click on this, it needs to be checked. After that, if we say OK, will print out now. Yes, it has printed. Yes, here you can see information related to the piles. Here is the pile material information. As can be seen, material information is provided here. Here, our pile information is given. As can be seen here, we have our capacity values. Here is number. Here, the specific characteristics are provided, and of course, the loads acting on the relevant piles are also given. And here, of course, it is marked as tick, because it is below the required capacity. There is no issue with this. Similarly, the control of the pala zimbalama is also being conducted here. Finally, the point displacements are shown here. In this way, you can also obtain the analysis results related to the clearances in the report. Yes, that's all I have to say regarding my pile modeling. Thank you very much for listening to me. I wish everyone good work.